Hello, Calculus, and welcome to 9.3. This is max and mins. Remember how your first derivatives found the max and the min before of a single one? It does the same thing in 3D. So now we're just going to apply it to a 3D point. I hope you're ready to go. Okay, make sure you have your homework out, and let's move. All right, so we're going to find the relative max and min, because on a 3D object, when it goes on forever, it's just like our other shapes. You could have points that go on, but over a section, it will have a max or a min, and relative extremas. Okay, so here again, if the point is greater than the function, it's going to be a max. If the point is less than the function, it's going to be a min. Nothing new. So this is what it's saying. So when you look at here, a relative max at AB, the AB is the top of the point of our shape, so it's a max. If it's at the bottom, then it's a min. We know that the tangents are 0. They're horizontal at those points, just like before. Now, here, if it's a saddle point, it can be a max of one point and a min of another. So like if you look at the parabola that's going this way, then that is a min. But if you look at the parabola that's going this way, then it's a max. So if it's max and a min, then it's a saddle point. And we'll learn how to find those too. So here, in order to find our critical points, we have a couple steps. First one, we find f of x, right? We got to know what's happening on the x-axis. Then we got to know what's happening on the y-axis. We're going to set those equations equal to 0 because that's where our horizontal tangents are. And then elimination or substitution, it's probably going to be almost always substitution because the elimination doesn't work well with these, but it is an option if it can be done. So our equation is f of xy equals 4x cubed plus 3xy plus 4x cubed. So you are right. Where did my pen go? Oh, right here. So now we have to do the derivative with respect to x and the derivative with respect to y. So the derivative with respect to x, so this is 12x squared, 3y, this one cancels. Now with y, this one cancels. We have 3y and 12y squared. Set those both equal to 0, so we have our horizontals at 0, just like before, because that's where we know our tangent point is. Sorry about that. Now we are setting these equal to 0, and it's too hard to do elimination on this one because here the x is squared, here the x is not, and the y is squared. So we're going to solve one of these for y or x. It doesn't really matter. I chose this one to solve for x. You could have chosen, for y. You could have chosen this one to solve for x. It's irrelevant as long as you plug it into the other problem. So I got this one equals negative 4x squared. So we're going to take this and plug it into this y value on the second equation. We're going to solve for x. Here I'm going to factor out a 3x, giving me a 1 plus 64x cubed. Well, this means x equals 0 here. Subtract, divide, and take your cube root. And we got x equals negative 40, or negative 1/4. I plug this value of x into this equation is what we're doing here. So y is equal to negative 4 times 0 squared, which gives us 0, 0. Again, negative 4 times negative 1/4 squared gives us a negative 1/4. That should have a negative there. Please fix that in your notes. And we have our 2 points. So I found the critical points. We literally don't know if they're maxes or mins or saddle points yet, but you know how to find them. And that's all I want you to do for the next one is actually find the critical point. So pause and give it a shot. So first thing you should have found f of x. So when you did that, you should have had 12x. This guy canceled. Plus 6y plus 36. Again, no x, so that one canceled. Now you should have found f of y. And first one canceled. You should have had a 12y here, plus a 6x here, and the last two canceled. All right, now you set both of these equations equal to 0. And when you look at this, these actually aren't too bad. We could have done elimination, but since there was only an xy on this side, I decided to solve this one here for x. It's truly whatever you feel like doing. So I subtracted the 6x divided by -6, so x equals -2y. We're going to take the -2y and plug it into my equation over here. So now we're taking this equation and we're substituting. So we've got 12 times -2y plus 6y plus 36 equals 0. We're going to solve this here for y. So -24y plus 6y plus 36 equals 0. That's going to give us a -18y. Subtract your 36 over. Out of room. Let's see if I can move this down a little bit. So then y is equal to 2. Now I'm just going to plug that in over here. So I've got -2 times 2 equals x. So x equals -4. We only have one point, and it is -4, 2. So we only have one critical point on this graph. All right, now I want to know if it's a max, a min, or a saddle point. So what we do is, these are the words. If you have to calculate what we call a discriminant. All right, so this point right here is what is very, very important. So we take the double derivative with respect to x times the double derivative with respect to y minus the xy derivative squared. All right, that gives us the discriminant. Now we take that discriminant and we have to decide if it's greater than 0. All right, then we have a max or a min. If the f of double x is less than 0, it's a max. If it's greater than 0, then it's a min. Now, if the d is less than 0, it's a saddle point. If it is equal to 0, we didn't get any information and we have to do something else. So we hope for less than or greater than. Less than is the easiest, I would agree. All right, let's see what we can do here. So step 1, we have to find our critical points. So to do that, we find f of x, 12x squared plus 3y. We find f of y, 3x plus 12y squared. We still have to find f of double x, which is 24x, double derivative with respect to y, 24y. And then the derivative of x with respect to y is 3. Because you're up here at this one. Don't forget what you're doing. All right, now this is the same one we found before. So if you look at our other page, we already found our critical points, and it was 0, 0, -1/4, -1/4. So first step is always critical points. So this is step 1, but we did that on the other page. This is step 2. This is figuring out if it's a max, a min. So right now we're looking for max, min, or saddle. That's what we're looking for. So we're going to test 0, 0. So we plug 0, 0 into f of x, it equals 0. 0, 0 into f of y, and we get 3. 0, 0 into double derivative of double y, and we get 0. We plug it into our discriminant function. So remember that's double derivative of x times the double derivative of y minus xy squared. So we've got -9. Well, -9 is less than 0, so it's a saddle point. All right, if it was greater than 0, then we'd have to check our other derivatives, which is what we're going to happen here. So now we're going to do -1/4, -1/4. We plug that into the double derivative of x, the double derivative of y, and xy. So we're plugging this into our other equations. We've got -6, -6, and 3. So now we do double derivative of x times the double derivative of y minus xy squared. And we've got 27. Okay, this is positive. So since this is positive, I have to check. So this means I have a max or a min. We do not know which one. So now that my discriminant is positive, I go to my double derivative of x, plug in the -1/4, and it is less than 0. So since that's less than 0, it's a relative max. Okay? I'm hoping you have enough work there to understand that. All right, give yourself a shot. Let's see how we do. I just want to make sure. So when you're up here, when I say we're plugging it into the double derivative, we're plugging it in up here, right? So we're taking negative 1/4 and negative 1/4 and plugging it into that point. So I'm really taking 24 times a negative 1/4, which equals a negative 6. That's why it's less than 0. That's why it's a relative max. Maybe we should have done that up here too. So we had the negative 6 here from up here when we did the double derivative of y. That's this one. So you're taking 24 again times the negative 1/4 right here, and that's where the negative 6 came from. Xy is right here. Since there's nothing to plug in, it is literally always 3. Okay, maybe that was a better explanation. Okay, let's continue and see how you do. All right, this is the same problem you did before. So you're using those same critical points that you've already found. And you're just going to tell me if it's a max, a min, or neither. So the only critical point we had from the other page was negative 4, 2. Okay, pause and try this. So you should have started out with f of x. That gave you, already found this, 12x plus 6y plus 36. Okay, then you had to find the double derivative. Forgot to put my xy in that other one. And the double derivative of this with respect to x is 12. And then the f of xy derivative is equal to 6. So straight numbers, we're not going to do a lot of work here. Now we have to do the double derivative of y. Okay, the first derivative was 12y plus 6x. So then the double derivative is equal to 12. We don't have a lot to plug in since we have no variables. So we take f of x, which is 12, times f of y, double derivative of y, which is 12, this is times, minus f of xy squared. So I got 12 times 12 minus 6 squared, so 144 minus 36 is 108. Okay, this is positive. All right, so we know this is greater than 0. So we have a max or a min. So now we look at f of double x. Well, f of double x is 12, so it's positive. So since this is positive, our answer is it is a min of the function. All right, I hope you did okay on that. Maybe you should have had a little more work, huh? All right, cost to produce one batch. And we don't know what soft drinks. So my cost is 2,200 plus 27x cubed minus 72xy plus 8y squared. X is kilograms of sugar. Y is grams of flavoring. What's the minimum cost is what we're looking for. So we got to find critical points first. So we're doing everything here. So step 1, critical points. Critical points is c of x and c of y set equal to 0. So here the 22 is going to cancel. We got 81x squared minus 72x, 8y is gone. C of y, again, that one cancels. This one cancels. Negative 72x plus 16y. Both set equal to 0. Choose one to solve for. Doesn't matter. They're both kind of ugly. So I just picked the y. We added the 72 divided by 16. So y is equal to 4.5xy. I'm going to substitute that in here. Kind of chose it so I didn't have to square it. So 81x squared minus 72 times 4.5. And we've got 324x. Factor it out, 81x. Well, that means x equals 0. Over here, x equals 4. All right, so now when I plug in 0, so up here we're going to do 4.5 times 0 equals y. So 0, 0 is a critical point. 4.5 again from here times 4 equals 18, another critical point. So now we got to check critical points for max or mins or saddles. So now we have to do C of double x, which is 162x, C the double derivative with respect to y, 16, double derivative with x then y, and we get negative 72 because everything's canceling out on us, right? Because you're up here is where you're looking with your derivatives. All right, so I got 162x. I'm going to plug in 0, 0. So the 0 cancels, and I've got a negative 5184. Well, negative means automatic saddle point, nothing else to do. So now we have to do f of double y. So we get 418 is what we're checking. So we do 162 times 4 plus 16 minus negative 72 squared. We get 5,184. All right, greater than 0, we have to check our f of x. So we're going to plug C of, this is our double x, is the one we're looking for. So when we plug in double x here, we're going to go here, we're going to get 162 times 4. So this again is positive, which means this guy is a min. If I want to know my min value, I will plug the 418 in, because 0, 0 is a saddle point, not a min. Plug it into our original. This should not have said double x, I'm sorry. Plug it into our original, and here is our minimum cost, $1,336. All steps done. Okay, pause and try yours. Okay, step 1, you should have found the derivative with respect to x, and you should have had 36 minus 3x. You should have done the derivative with respect to y, and you would have had 120 minus 4y. Okay, double derivative is just equal to negative 3. Double derivative with respect to y is equal to negative 4. The derivative of xy, if you look here, this one's really weird, right? Because it's just a number, so that equals 0. So now when we look at this, we have to solve these. Well, this one here is easy to solve, so we got to find our critical points, right? That's just our work. So critical, we're going to do p of x, 36 minus 3x set equal to 0. So x is equal to 12. Well, the same thing over here. We're going to do p of y, set that equal to 0. So y is equal to 30. So we have my critical point of 12, 30. So we've done first step. Now we want to know if that is a max or a min. So your second step is we have to calculate your determinant. Okay, when we calculate our determinant, so we're going to take the double derivative with respect to x times the double derivative with respect to y minus the xy squared, and we've got 12. All right, 12 is greater than 0, so we either have a max or a min. So since I either have a max or a min, we have to double check and oops. All right, so since it's a max or a min, we have to double check our f of our p of double x with respect, and we know that's a negative 3. Well, since this is negative, that makes this a max profit. So our max profit is 12. It's in thousands of dollars. So whoops. So it's $12,000 or $100. Better double read my thing. I think it was 1,000. No, hundreds. So we got 1,200 is our max profit. Okay, good luck on your homework. I hope you do well. Make sure you post questions if you have any.